Hi everybody, today we is going to see routing ranges problem. So this problem is medium in Leetcode. So what this problem statement is, given an orange in a particular cell in a matrix, and if it is rotten, all the adjacent cells surrounding that orange would become rotten every minute. So the algorithm for this would be we need to have a track of what all oranges changed from fresh to rotten. From 1 to 2, what all oranges which have changed, just track that and do not make changes to those oranges when you're changing it. So that is very, very important step in this particular problem statement. So we will have a Boolean rot to verify if a particular uh, grid is having a rotten orange, and we will loop across tracking the changed cell. So that is pretty much what this problem statement solution would be. So I'll just go through the algorithm here, verify, just create a variable rot equal to true and loop through it till rot is true. And if 2 is present in the grid, so adjacent to 2, if anyone is present, then you initialize rot true for the future loops. And also track this change cell in a list. So verify all the tracked cell is not changed in that particular loop. So pretty much, so I will just start coding now because I'm sure what I need to do. So I'll have a variable count to count the number of times the changes has to be done. So while rot, so I'll just make this false in case there are no dot and oranges present. So I'll increment the count and I'll have a list for changed. Okay, and I'll loop across. Length of column, that is grid 0. So here what we need to do is, if the grid ij is equal to 2, then we need to make changes. And also we should make sure that this ij is not in our changed cell. So it is not changed now, it is changed before the loop started. So this is 2. Then we need to track the 4 directions of the particular cell to check if it is 1. So this, for this we'll have one small function just to track. So we'll have called change, or we'll just say verify borders. So if it is going beyond the border, we'll return false. If it is staying in the border of the matrix or the grid, it will return true. So the condition for that would be 4 conditions. If I is less than 0, or I is greater or equal to the length of the grid, the rows. Similarly, if column is less than 0, which is j, or column should be greater than or equal to length of the grid 0. So in this condition, we'll return false because it is going beyond the boundary. So false is represented as 0, and we'll just return true here. So this would give this function will help to get the borders correctly. So what I'm going to do is, if verify border returns me true, then I would check if that particular value of that grid is 1. So that is what we're going to do now. So the 4 is I plus 1 j first, so which is nothing but below one row. and then we verify if the grid I plus 1 j is 1. So if it is 1, we can change it to rotten, which is nothing but 2. So we'll just change it to 2, and along with that, for the future loop, rot is true, so the rot will run then in the next function. And also we need to track of this I comma j in changed, so append this in changed. Okay, so this should be I plus 1 comma j. So repeat this logic for the remaining 3 boundaries. So we'll just copy paste 3 times. So we need to verify this for I plus 1j, I minus 1j. Similarly, you need to do for I j plus 1 and I j minus 1. I j plus 1 and then we have I j minus 1. These are the 4 boundaries which we need to verify for all the rotten oranges. So that is, let's ij plus 1 and ij minus 1. Yeah. Okay, so I'm just checking I plus 1j, I minus 1j, ij plus 1 and ij minus 1. So we're good. Okay, then we would print the count to check. Yeah, the count it's giving 5. So why 5 is we will have always one false added to it. That is why it's returning 5. So this is what is expected, and yep. And we have one more condition to check if there are no rotten oranges, uh, which is over here. Uh, so after converting this, if still there are any fresh oranges present, then we need to return -1. So we just need to loop this one more time to check if there are any fresh oranges present. Even after converting it, if there are fresh oranges present, then we need to return -1. So just check if grid I j equal to 1, then you return -1. So this is that, otherwise you return count -1. So why we give count -1 is so once the loop gets entered, it has to check for false at least once. So always the loop run once. So at the end of the result, you have to subtract that particular default loop from it. That is why we are giving count -1. So we would check with examples, and then we can verify is this correct or not. sure this works. So the examples are pretty good in this particular problem, so we can just submit it. Uh, so yeah, this works. You can see that this is work. The basic thing to understand for this problem statement is how do you track changes every loop. So we use a list to track it, and we append it once the values get changed. So that's the important concept and takeaway for this particular problem statement. And thanks a lot.